will be below the gamma is given by PR distance as d greater than the received power is less than to the arbitrary, then the quality function is not given by received power to gamma to sigma. It is question number 9. These are the two main equations. If the actual signal which is fell on your systems is not in your mean, is not in your log normal distance, then we have taking the probability density function q functions. If the gamma is this threshold value gamma, if the received power, the actual signal is out of this received power, then the gamma function is arbitrary and it takes the extra amount of energy to receive this cultured signals and within your band signals and provide the signals strength in the receiver from the coverage several area. So what we do now, we do the determination to calculate this gamma threshold value, determination of percentage of coverage area. This is the important point, and it is clear that the random effect of shadowing some location within the coverage area and will be below the particular desired received signal threshold. It is often useful to compute how the boundary coverage relates to the percentage of the area covered within these boundaries. So the average relates to the percentage of area covered within these boundaries. For example, for a cellular coverage area having the radius of r from the base station and let there be the some desired received signal threshold, we are interested in computing this function u of gamma. This is the percentage of useful service area, that is the percentage of area with a received signal that is equal or greater than gamma. Either it is the greater than gamma or either this signal is less than, that is depends on this received percentage of u of gamma. To give the known likelihood of the coverage at the cell boundary, so assume that d, your distance, separation distance is equal to this cell radius small r, represent the radial distance from the transmitter. It can be shown that PR is greater than that thresholds gamma. This is the probability that the random received signal at d equal to r and exceed the threshold value gamma within a incremental area, that is the known as area dA. This is the extra incremental area dA. Then this u may can be found as can be given by u of y is 1 upon pi square, because the several boundaries are considered. It is greater than threshold value, and this is the incremental area. This is given by 1 upon pi r square. Limits for this boundary of several and the cells is PR is greater than gamma and r radial distance and d theta. This equation is number 10. And using this 8 equation, okay, using this 8 equation, then this equation 10, it becomes like using equation 8 in 10, equation 10, then this equation becomes like PR received power is greater than threshold value, then the quality function is greater than threshold value due to the means, and it is given by half minus half, that is the error function. This is greater value at the received threshold value to the sigma r square. This is actual equation to determine the values. Now again it is simplified, 1 by 2 minus half of ER of and gamma, that is threshold value, transmitted power PL do not plus log than log d theta and sigma r square. In order to determine the path loss or a reference to the cell boundary, then small r is equal to the several boundaries, then it is clear that PR, that is path loss distance at r, is given by 10 and log r upon d naught plus 10 and log r upon capital R plus PL do not. It is the equation number 12. Now further simplified this equation, and the expression, this equation can be write as 1 by 2 minus 1 by half RF gamma P of t PL do not plus 10 and log r d naught plus 10 and r sigma root square. This is equation number 13. So this is bigger equation, so let him assume some component, the threshold minus transmit power plus PL do not from the above equation is equal to small a, and divided by sigma square and log E upon sigma square. After putting this, then u of gamma 1 of half of r square 0 to r erf, it is a plus b natural log of dr. This equation is 14, and by substituting the t is equal to a plus b log r by r in equation number 14, then it becomes u of gamma half 1 minus er of a plus e 1 minus 2ab divided by b square and 1 minus erf 1 minus ab of b. This is equation number 15. By choosing the signal level such that the received power in a several system, it is arbitrary equal to threshold value, that means a is equal to 0, then u of gamma, this equation becomes half 1 plus exp upon b square upon 1 minus erf divided by 1b. This is equation number 6. So equation 15 is evaluated for a large number of values of sigma and n. Sigma, mean values, and n. And that is the exponent value as shown in, we have know that, for example, if we varies the signals taking the different areas. So it is the end of today lectures. Thank you very much. We hope you are safe in the home, and we also hope you are doing well, you are reading at home, and if any problem you can contact me, or you can solve the problems. And I give you one more exercise for the in next lectures for the solution, or that is important in previous, since there are a lot of things are we have derived in previous lectures. We have seen the path loss in free space. We also seen in path loss in two-ray model. We have seen the path loss in long distance in analytical approach. We are also seeing in practical scenario log normal shadowing, path loss derivation. Under this assumption, thank you very much.